So, Bismillahirrahmanirrahim. I'm Talha NIsar. I will be your lecturer and I will teach you physics on the intermediary level. So, before starting the first chapter, we have to introduce the physics itself. What is physics? Physics is the study of matter and energy. So, physics is the study of matter and energy and their mutual relationship. So we have two main different types of physics. One is the physics of very small. Physics of very small, and then we have the physics of very large. So what does that mean? So the physics of very small is the physics which deals with the study of the extremely small particles like atoms, molecules, or subatomic particles. So this type of physics is usually called the quantum mechanics. And the physics of very large means the physics in which we study the stars, the galaxies, and the whole universe itself. This is explained by the general theory of relativity. But the physics that we will dealing with, or we will discuss in this course, will be mainly the Newtonian mechanics, which is in between these two. So we will be talking about the Newtonian physics, which explains neither the very small things nor the very large things, but Newtonian physics explains the normal the things that are happening around us in our daily lives. So this is the quantum mechanics, and then we have the theory of relativity, but here we will be talking about the Newtonian physics. So we will talk about the Newton laws, which will explain how the things are moving, how the earth is rotating around the sun, so this type of things. So now we come back to the physics, the definition of physics. So we said that we have the matter. So on one side we have the matter, so the study of matter, and we have the energy. So what is matter? So the matter is anything that is solid that's around us. For example, any bulk matter. Bulk matter means which we can feel. For example, this chalk, my body, or everything that's around us, that's called the bulk matter. It's not the small particles. And then we have the atoms, we have the molecules, and we have the subatomic particles. So these are the different types of matter. That's possible matter. For example, the bulk matter. Bulk matter is something which is not very small. So anything that we can see around us, that's called the bulk matter. And then we have the very, very small matter, which is the atoms, or we also have the molecules, which is made up of the atoms then. And then we have the subatomic particles like electrons, and then the protons, neutrons, or other subatomic particles. Energy, we have, for example, the gravitational potential energy, we have the potential energy, we have sound energy, we have the light energy, we have the space-time, we have the nuclear energy, and we have the kinetic energy. So now we have as we said, that the physics is the study of matter and energy and their mutual relationship. So we have the bulk matter here, and then what we do in physics, we study these matter and energy, and we want to see how they are related. For example, potential energy. Whenever we have, for example, I have this notebook, if I raise this object in the gravitational field, due to its position in the gravitational field, this matter, which is a bulk matter, it will have the potential energy. Similarly, the sound, how the sound is produced. So the sound is produced whenever something is vibrating, it's disturbing the medium, which is the air. The disturbance is produced by the material, and then it's carrying the energy. So this sound, this is how the sound is produced. If something is vibrating 20 times in a second, which is also known as the 20 hertz, then we will be able to hear that sound. So the sound is the energy which is carrying actually the sound is the form of energy, and it is produced, or which is related somehow to the material. Sound cannot exist without the presence of material. Similarly, how the light is produced. The light is also produced because of the material. So the light is produced when the electrons, the subatomic particles in the atoms or molecules, are changing their positions in the electric field that's present in the molecules. So that we will discuss these things later, but just to give you an idea what actually the physics is, means what is the relationship between the matter and the energy. So the light is produced because of the matter. When we excite the atoms and they go back to the ground state, so this is how the light is produced. But it's also somehow related to the matter. So we relate the energy with the matter, and then we study it and we try to understand how the universe actually works. Similarly, the nuclear energy. So the nuclear energy, you can see here, related to sometimes, so the nuclear energy, again, you can see from the name itself, nucleus is there. So this nucleus is the nucleus that is present in the atoms. So this nuclear energy is keeping the protons inside the atom. And then we have the kinetic energy. The kinetic energy is due to the motion. So when something is in motion, something is moving, it has the kinetic energy. So this is associated to the moving objects. So the objects are the matter, and then the energy that is associated with their motion is the kinetic energy. So why do we study physics now? We study physics, so we see these are the old things, or almost these are the things that actually exist in the universe. So what we do in physics, we study these things and try to understand the universe, how the universe works, how everything around us, how they are working. So the importance of physics. So why do we study physics? For example, we have the examples are the airplanes, how airplanes are floating in air. Why are they not going down? And that's because of the physics. That's because we can explain this by the knowledge of physics. The electricity is almost everywhere nowadays. The cell phones, the cars are moving because of electricity. Our body requires electricity. Yes, of course, the heart, for example, our heart requires electricity. So the human body, the microwave, how the microwave oven is working, for example, the sun, the earth, the cars. So all these things requires, or they are working because of the knowledge of physics. So we can explain or understand these things with the knowledge of physics. That is why we study physics. Now we come to the measurements, or we come to the physical quantities. Physical quantities. So any measurable quantity is called the physical quantity, anything that can be measured. For example, if we have a mass, if we want to buy something, we go to the supermarket, we want to buy something, we want to buy a rice. So what we do, we measure the rice and then we buy it. For example, we want to buy 2 kg of rice, so we have to measure it. So how do we measure these physical quantities? For example, we have the mass, we have the time, we have the temperature. So for that, we have the base units. So we have the base quantities, and then we have the derived quantities, derived quantities. So the base quantities are, so we have the length, we have the mass, we have time, we have the amount of substance, and then we have the intensity of light, intensity of light, and electric current, So these are the base quantities. So whenever we want to measure the length of something, this is the base quantity we can measure. So we have the mass. So mass is, whenever we want to measure the mass of something, we measure it in the kilograms, the micrograms. We have the time, we have the amount of substance, and then we have the intensity of the light, and then we have the electric current. So these are the base quantities. So based on these 7 basic quantities, we can have the force, for example. These are the derived quantities. So force is a derived quantity. See, we will discuss these things in detail. So we have the acceleration here, and then we have the velocity, we have the volume, and then we have the area. So these are the derived quantities. So here the base quantities are important. So how do we measure the base quantities? So we have, for example, for the length, we have the centimeter, we have the inches, we have the meters, we have different type of units. For example, the astronomers use the light years. Light years is a distance that is the light travel in 1 year. So which unit should we use to express these quantities? So the scientists developed a system, it's called the International System of Units, which is internationally recognized as standard system. So we have a standard units which is applicable throughout the world. So we will talk about these now. So we have this international system of units. So we will now talk about the international system of units. So we have so this is all system international. So it's also called as the SI units. So we have the physical quantities. So we have the physical quantities. So we have number 1 is the length. We have the mass. We have time. So we have the electric current, we have the amount of substance, amount of substance, we have the intensity of the light. Intensity of light. So these are the physical quantities as we just talked about here. So these are the same quantities. Now we have the international SI units. So they are SI units. SI units. So for the length, we have the meter, and its symbol is m, small m. For the mass, we have the kilogram. So its symbol is kg. And for the time, we have the second, which is represented by S. Then we have the ampere. We have for the electric current, we have the ampere, which is represented by A. For the amount of substance, we have mole, which is represented by MOL. This is MOL because we already have M here. So this is the intensity of the light is candela, which is represented by CD. And then we have another, so this is 1, 2, 3, 4, 5, 6. So we have the 7 international base physical quantities. And the 7th one is the temperature. Temperature, its unit is Kelvin, which is represented by K. So these are the physical quantities, as you can see. So we have here the physical quantities. Based on these physical quantities, we can derive many other units. Now, so we talked about the base quantities, and now we come to the derived quantities. So we have the derived quantities, derived quantities, or derived units, quantities. So the derived quantities, we have the one example is the force. So why are these quantities called the derived quantities? Because these quantities that we will discuss right now are derived based on these base quantities. We cannot derive these quantities, but we can derive these quantities which are based on the base quantities. That's why they are called the fundamental base quantities in physics. So its unit is Newton, represented by N. So now, since we said that they are derived from these quantities, so we can write here the kg. So this is the unit. This is equal to meters divided by second. So now we can see here we have the kilogram, which is the unit of mass here, and we have the meter, which is the unit of meter, which is the unit of the length. We have the meter, and then we have the second. So this is a derived quantity which is derived from these base quantities. So other example would be, for example, work. Work, its unit is joule, represented by J. So now we come to the, so its Newton's meter, and also, so this is the Newton's meter, so we know what is Newton. So Newton is kg meters per second, and we have, since we have another meter, so meter square. So we can again see here we have the kilogram, which is the base unit or base quantity. We have the mass, which is the unit of the length, and then we have this another base quantity, which is the unit of the time here. So we have different types of quantities. So we have other examples, or for example we can have velocity, we have the acceleration, we have the power, we have the charge. All these quantities are derived from these 7 base quantities. So these are the 7 base quantities, and all other quantities, whatever you see in the physics book, those quantities will be derived from these base quantities. Now there are some quantities, they are neither the base quantities nor the derived quantities. They are called the supplementary units. So what are they? So we have the angle. So the angle, so we have 2 types of angle. What is angle? So we have, for example, 2 lines here. So this is called the angle, which is usually represented by the degrees. Now, for example, this is, for example, not 90 but like 70 degrees. So degrees in degrees, but the SI unit for 2D angle. 2D means this is the 2D, only 2D plane, 2D angle. So for the 2D angle, the unit of the 2D angle is radian. What is radian? So for example, we have a circle and we circle, so this is the R is the radius. So we increase the angle, for example, with respect to this radius, and when we come to the arc, which is equal to the radius, so this a distance and the R, when they are equal, so this angle is called 1 radian. So radian is the supplementary unit, and then it's a standard unit, so we commonly use the degrees, but we don't, the standard unit is the radian, and 1 radian is when the radius is equal to the arc. Arc means which is any area or any line on the circle. And now we come to the 3D angle. So the 3D angle, what is 3D angle? So this circle is the 2D, two-dimensional structure, but we have, what if we have the 3D, three-dimensional structure, how do we define the angle for that? So if we have, for example, a ball or spherical object like, for example, our Earth. So first of all, the 3D angle, the unit is called steradian. So how do we define a 1 steradian? For example, here we define what is 1 steradian. So we have the circle, for example, and not circle, the 3-dimensional object. So this is just to give you some idea. So from the center, this is the area. So this is the area on the surface of the ball. For example, we have a spherical object, for example, a ball. So this one is the area which is on the surface of the ball. So when this area, so this is the radius, this is the radius of this spherical object. So 1 steradian is when the area of this surface on this ball is equal to the square of the radius. So this is how we define the steradian. So now we talk about the scientific notations. Scientific notations. So scientific notations are when the numbers are written in terms of the power of 10 and one non-zero digits left in the decimal. So what does that mean? So whenever we have a very, very large number, for example, we want to write what is the mass of the earth or the mass of the sun. It's extremely huge number with the many zeros. So it's difficult to read those numbers. Similarly, if we have a very, very small number, for example, the mass of the electron or the mass of the atom, they are extremely small numbers with the 30 zeros. Or more than 20 zeros. So it's difficult to write or read those numbers. So we have developed, or scientists have developed, a way to write those numbers to extremely small or small numbers, small or big numbers, to understand or write it better. So for example, we have a number which is 134.7. So we have this number which is a random number. So it's so this is a normal number, but in the scientific notation, how do we write it? So we write 1.3, we write 47 multiplied by 10 raised to the power plus 2. So why do we write it like this? So in the scientific notation, what we do, we bring this point to here and we left one digit here, and then what we do, so we brought this point from here to here, and we see here there are two digits here, so we brought it to the here. That's why, since there are two digits here, we write to 10 raised to the power 2. Similarly, we have another example. So this is a kind of big number. Example of the big number is not really big number. If, for example, we have the mass of the sun, which has like 30 zeros. So what we will write, we will just write one number here and then point something and then 10 raised to the power 30. So that's easy to write instead of writing so many zeros there. So the other example is for the small number. So we have the 0.00023. So this is a small number, which is a very small number. So if we want to write it in the scientific way, so we will write, what we will do, so we will leave only one digit here, so which is 2 here, and then 2.3, so 2.3, so we leave here one digit, and then we just proceed there, and then before the point we leave one digit, and then we write 10 raised to the power -3. So why do we write -3? Because you can see here there are 3 digits between these 3 points. So what we do, we brought point from here to here, and then we have 1, 2, 3. So we have the 3 digits. So this is the scientific notation. We write very small or big number in this way. So if these numbers are very small or big, so we have a specific prefixes for that. So prefixes, for example, if we have 10 raised to power -9, So this is called nano. So if we have 10 raised to the power minus 9 means 0.0000 means up to 9 zeros, and then we have the number, and then this is the, for example, nanometer. So we will just write this. So for example, we can just write the nanometer or nanokilograms or nanohertz. So for example, we have the other one is minus 6. This is called the micro. For the 10 raised to the power minus 3, which is here, this is called milli. So also we have the deca, we have the centi, we have the kilograms. For example, if we just turn it to plus, then it will be kilogram, which will be 1000. So for example, we have here 1000. We write this 1000 when we write in the scientific notation, we will just write, ignore these 3, and then we will have 10 raised to the power 3, and this is called kilo.